myself Shekhar from Government Polytechnic College Sikar. Today in this lecture, first we will explain the types of induced EMF and then the working of DC generator. EMF induced EMF is divided into two parts: statically induced EMF and dynamically induced EMF. Statically induced EMF is again divided into two parts: self-induced EMF and mutually induced EMF. First is self-induced EMF. Voltage induced in a coil due to change of flux produced by itself is called self-induced EMF, and the value of self-induced EMF is given by VL is equal to L di on dt, where L is inductance of coil and di by dt rate of change of current in coil. Second is mutually induced EMF. Mutually induced EMF induced in a coil due to change of flux in a nearby coil is called mutually induced EMF. And the second type of induced EMF is dynamically induced EMF. Dynamically induced EMF, and the value of dynamically induced EMF is given by this relation: E is equal to BVL into sin of theta, where B is flux density in Weber per meter square or Tesla. V is relative velocity between field and conductor, and L is length of conductor. Theta is angle between V and B, direction of movement of conductor and flux density. Theta is angle between V and B. So this much voltage is induced in the conductor, and the direction of this induced EMF, is given by Fleming's right hand rule. And according to Fleming's right hand rule, if we stretch the first finger, middle finger and thumb of the right hand mutually perpendicular to each other, then if the first finger indicates the direction of magnetic field, thumb indicates the direction of movement of conductor, then the middle finger will indicate the direction of current or direction of induced voltage in conductor. So in this case, in this figure, if the movement of conductor is inwards towards the board, then the polarity of induced voltage will be such as to produce a current in downward direction. And if the movement of conductor is out from the blackboard, from the board, then direction of magnetic field, direction of movement of conductor and direction of induced current will be in upward direction. So if we move the conductor towards the board, then direction of induced current will be in downward direction, and if we move the conductor outwards, then the direction of current will be in upward direction. So the magnitude of induced EMF is given by this equation, and direction or polarity of induced voltage is given by Fleming's right hand rule. Now we will explain the working of DC generator. Working of DC generator. DC generator is used for converting mechanical energy into electrical energy. In DC generator, the input power is mechanical power and output power is electrical power. To explain the working of DC generator. Consider a single turn coil rotating in the magnetic field produced by this permanent north and south poles. The line of magnetic field will start from the north pole and terminates at the south pole. So that magnetic field is in this direction. The lines of magnetic field starts from the north pole and terminates at the south pole. In this magnetic field, if a single turn coil ABCD is rotated in clockwise direction, then this flux between the north and south poles is cut by the two sides AB and CD of the coil. And when the coil is rotated in clockwise direction, then first consider, suppose at starting the coil is at right angle to the magnetic flux, then maximum flux is passing through the coil, but rate of change of flux is 0. So voltage induced in the coil across the terminals will be 0, and this induced voltage is represented by 0.1 in this figure second. In this figure second, and this is figure first. So when the coil is stationary at right angle to the magnetic flux, then flux passing through the coil is maximum, but rate of change of flux is 0. So voltage induced in the coil will be 0, and this is 0 voltage is represented by this figure, this point 1 in figure second. Now as the coil starts rotating, then for the rotation 0 to 90 degree, in this position the flux passing through coil is 0, but in this duration the rate of change of flux is maximum. So maximum voltage will be induced in the coil, and this is represented by figure. This is represented by point 2 in figure second here. Now for the next quarter rotation, the coil rotates through 90 to 180 degree, and in this position the induced voltage is represented by this portion of the coil. For the third quarter, now at starting जिस प्लेन में मैग्नेटिक फ्लक्स एंटर कर रहा था उस फ्लक्स से मैग्नेटिक फ्लक्स निकलेगा. सो द डायरेक्शन ऑफ इंड्यूस्ड वोल्टेज विल बी reversed, and for the next quarter the value of induced voltage is represented by this portion of the coil from point 3 to point 4, and for the next quarter from 270 degree to 360 degree, 270 degree to 360 degree, the induced voltage is represented by this part of the curve, and this completes one cycle of induced voltage in the coil for one rotation of the coil. Means when a single turn coil rotates between two magnetic poles, then for one complete revolution of the coil, one cycle of voltage will be induced in it. Or in other words, when a conductor moves from north to south pole and then south to north pole, then a complete cycle of voltage will be induced in the conductor. Now the voltage induced in armature winding of DC generator is of alternating nature, and this alternating voltage induced in the armature winding is converted into DC voltage by a mechanical rectifier, and the device is called commutator. Commutator is made of hard drawn copper segments, and it is mounted on the rotor shaft. The armature winding is connected to commutator segments, and this commutator converts this alternating voltage induced in armature winding into unidirectional voltage and this unidirectional voltage then through brushage supplied to load. So voltage induced in armature winding is of alternating nature and that is converted into unidirectional or DC voltage by the commutator.